Hello, this is the chapter 1, remote sensing, and this chapter is divided into 8 subsections. The first section is introduction to remote sensing. So, what is remote sensing? Remote sensing is understanding of the surface of the earth without uh, physical contact or from the distance, and it is done by measuring the radiation which is reflected or emitted. So reflected part is the visible part and infrared part, while the thermal part of the energy is emitted here. So this is all done to understand the Earth's surface. It's a data analysis of the surface of the Earth to extract the meaningful information. So this is about the remote sensing. When we see the principles of remote sensing, principles means what we need to know remote sensing. We need to know about the energy source, which is very important. That radiation has some characteristics like the electromagnetic spectrum divided into different bands. So when we get the data into different bands. So for that, we need to know the characteristics of the energy source, that is solar radiation or sun radiation. So before reaching to the surface of the earth, this radiation first interact with the atmosphere. There is much more part of the radiation which is absorbed in the atmosphere or scattered in the atmosphere. That is also important to know. Then comes to the surface interaction. uh, Whatever there, the surface of the earth, whether this is plants, maybe in the form of trees or some another type of vegetation. There is a water, there is a sand or snow or another like barren area. So all these objects have different interaction with the sun energy radiation or the another kind of energy, maybe microwave energy. So it's for remote sensing, I mean, we need to know that what is the interaction, how energy interact with different types of objects. Then we need to know about the sensors because different programs are there like Landsat program, Sentinel program. These programs have these sensors and these sensors have characteristics. So we need to know that what are the characteristics of the sensors because we have to write. When we do analysis, data analysis, we have to write the sensor characteristics. Then the data processing is this is the part when you use your data for satellite data for remote sensing analysis. These are the principles of remote sensing. When we come to the component, the same components are here arranged in a orderly manner. First, we need to know the sun energy, that is the sun, then interaction with the atmosphere, then interaction with the surface objects. So B part is given here because there are two types of remote sensing. One is passive remote sensing, which is dependent on the sun energy. Another is active remote sensing. So in active remote sensing, the energy is produced by the satellite. So here this is B. There are two B. The first B is for optical remote sensing and or passive remote sensing, and this B is for active remote sensing. Okay, so from C here the satellite will detect that energy and will give the ground station in the form of images, and these images we do analysis with our computer and we extract the meaningful results here. So all these are the components of remote sensing. So here as I was talking about two types of remote sensing, passive and active. Passive remote sensing is dependent on sunlight. Okay, the first the energy direct with object, then it is this reflection is detected by the satellite. And the second type of remote sensing is active remote sensing. These are the examples. Here the sun energy is not being used, but the satellite produced its own energy and then received that energy. Both type of remote sensing are important, but there are certain limitations. When there is a sun, the in between sun and earth there are clouds. So what happens, the wavelength is not as long. uh, there is some short waves which are being affected by the clouds. So wherever the cloud cover is there, we cannot do remote sensing. So this is the drawback of passive remote sensing, but this is not the matter with active remote sensing. In active remote sensing, uh, the waves are longer and does not affected by cloud cover. These waves penetrate to clouds, and then if there is a cloud cover and if there is no sunlight, then also we can do some remote sensing with the help of the radar data or lidar data or synthetic aperture radar SAR data. So these are the types of remote sensing. Now we move to 1.5, that is electromagnetic radiation. So electromagnetic radiation is related to the first component. We are talking about the sun. So this is the energy. We should know the energy characteristics. There are different bands, different regions. The first part is gamma rays and X-rays, which are very short wavelength. They have high energy. So these are not used in remote sensing. Ultraviolet rays also useful for remote sensing, but much of ultraviolet radiation is being absorbed by ozone. We know that. Visible light has wavelength from 0.4 to 0.7 micrometers, and this part includes the colors, and this visible light is being detected by our sensors, which are eyes. So eyes detect this visible light, and then and this is the limit. I mean, our eyes can detect only visible light. Our eyes cannot detect UV, cannot detect infrared or another energy, but only visible part. But in remote sensing, the man-made detectors can detect some part of ultraviolet radiation and infrared radiation also, and microwave also. So what happens, the remote sensing makes us very powerful to use the energy beyond visible light. So this is the uh, the significance of remote sensing. And the remote sensing, in remote sensing, especially in passive remote sensing, this part is very important here. This part is very important. Okay. This part is very important. We'll discuss in detail this one here. Draw, erase. Okay. Okay, so visible light here important. Infrared is very important. The reason is the near infrared red is very sensitive to plants, green leaves, helps us to analyze the green vegetation very well. And then there is short infrared also, which is little far or little longer than near infrared, that is used for uh, vegetation water content or open water sources. So here uh, the important part is to understand that we will use visible light, we'll use infrared light in remote sensing. Okay, and these are the wavelengths given here, right? Now we move to applications of remote sensing. Remote sensing can be used for environmental monitoring, agriculture, planning or plant health, soil moisture, urban planning, disaster management, natural resource management. So there are many uses of remote sensing. This is the reason that this I mean the remote sensing day by day is getting popular and very important to do all these things in very short period of time. We can do analysis for longer area, for larger area, so quick. So these are the, here you can see the advantages of remote sensing: cover larger area, provide the data which is not accessible easily. I mean, you are sitting here in Nigeria, you can do analysis for another any part of the world where you are getting the satellite data. Uh, okay, then the limitations are there, especially for passive remote sensing. Cloud is a big problem. We cannot do correct analysis if the cloud's cover is more. That's why we, before using the satellite data, we ensure that how much cloud cover is there, and we remove that area from the analysis where clouds are there. Not only clouds, cloud shadows also, which are at the surface of the earth, affect the data quality. And what is the relevance of remote sensing in Nigeria? We know that in Nigeria, uh, uh, I mean, more people do agriculture, so we should know that how this agriculture is being practiced, what is the area, and how this agriculture is being affected by another natural calamities, natural disasters like the floods or the drought conditions. So with remote sensing, it is easier to do such kind of assessment. We can do environmental management, disaster management, we can do urban planning, and we can look at the resource exploration also. So this is all about the chapter 1, which is the remote sensing, introduction of remote sensing. Now we'll move to chapter 2,